SAS class with Amanda. Hey. Hello, in this video we continue discussing confidence intervals, and the entire purpose of this video is to understand in more detail how the margin of error and confidence level relate to one another. Okay, so let's just remember what the confidence interval formula was. It's x bar plus minus z star sigma over radical n. Okay, all right. So how can we get a smaller margin of error? Remember, we want to be as accurate as possible. We want to be able to estimate our mu very, very well. So we can get smaller margin of error, which implies better accuracy, if we do the following three things. One, we can decrease sigma, right? So this fraction will become smaller, and when you're multiplying by a small value, this entire margin of error becomes smaller. Two, z star could be small. You can make that small for the same reasons as stated for number one. Remember, z star, though, represents confidence level, okay? So the smaller it is, the lower our confidence. And you can look at table C and check for yourself, okay? So if we look at table C, notice here that as we move to the right, z star gets larger, okay? If we want a smaller z star, notice what happens to the confidence level. Moving to the left, smaller z star, we get lower and lower confidence, okay? So we don't like that idea. So 2 is automatically scratched out. 3, the next thing we could do is increase n. All right, so first let's talk about decreasing sigma. Why is that a bad idea? Well, we have no control over it. So we can't do that. And decreasing z star is also a bad idea. So increasing n. Is this something that we can do? Well, it can be inefficient. Okay, so increasing n makes this a smaller number, and again, multiplying something by a small number makes it smaller. So it can be inefficient. So we need to choose carefully. So let's talk about how we can choose that carefully. Right? So the relationship that we're talking about between margin of error and confidence interval is stated in these 3 points. So you should take some time and make sure you understand what's going on here. So we can determine a proper sample size by looking at the margin error, which we said is z star times sigma over radical n, and we want to solve for n. Okay, so in this scenario, we've selected our margin of error. Let's say it's 0.01. Okay, let's say also ahead of time we decided we want our confidence interval to be, 95%, which we saw is 1.960. Okay, let's say our sigma is already given to us, and we're trying to solve for n. Right? So let's go ahead and use our algebra skills and solve for n. You should find that n is equal to z star times sigma over m squared. Okay, so here margin of error has to be selected ahead of time. Z star has to be selected ahead of time. Sigma we have no control over, but it has to be given to us. And then we're able to determine what n is. Okay, we don't want n smaller than that, right? Because if n is smaller than this, then we have a larger margin of error. Remember looking at this, larger margin of error if n is small. If n is larger than this, then we're dealing with this inefficiency. Okay, so this formula helps us choose a more accurate sample size, or not a more accurate, but a better sample size. So let's let's use this example here. Okay, so we want a 99% confidence interval. So let's look at table C and check out what Z star gives us 99% confidence. Here's 99%, it's the first full column on the right. And we see that is 2.576. So 2.576. Will the margin of error be larger or smaller than the margin of error for the 95% confidence interval? So remember that Z star for that is equal to 1.960. We want to know whether the margin of error will be larger or smaller than this margin of error. So what do you guys think? Sigma's already selected. It's assumed, I guess, that n is already selected, and we're multiplying by this Z star here. And then again, Z star, sigma, and n radical n are the same. So essentially what we're comparing are just the Z stars. And so the margin of error should be smaller when we're talking about 95% versus 99% confidence interval, margin of error will be larger.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.